So now we've talked a bit about genes and a bit about the environment. But what we know using this lifespan developmental perspective is that genes and environment often interact. I mean, when it comes back to the nature-nurture debate, we don't think about it as 80% nature and 20% nurture, but it's an interaction between the two. So we need to discuss these paths from genes to behavior. And there are two ways that we can think about this interaction between genes and the environment. So we can look at gene by environment interactions. We can also look at gene by environment correlations. So we're going to talk about both of these. Let's start with the gene by environment interaction. Most researchers today view development as the result of a dynamic interplay between heredity and the environment. So we cannot think of development as a linear spectrum, but as a dynamic, reciprocal interplay between nature and nurture. So individuals might respond differently to the same environment because of genetic makeup. At the same time, you might see a similar response that could result from different gene by environment combinations. So a gene-environment interaction is the idea that because of their genetic makeup, individuals differ in their responsiveness to qualities of the environment. They display unique, genetically influenced reactions to particular experiences. In addition, similar responses can result from these different gene-environment combinations. So I want to give you an example, and this example is about stress and depression. So there's a theory, and it's known as the stress diathesis theory. And the stress diathesis theory suggests that an individual's depression manifests only after exposure to stress. So evidence of gene by environment interactions support this theory by demonstrating that a certain gene negatively alters affect or emotions only when paired with stress exposure. Although there is a generally strong link between stress and depression, contextual factors like the type of experienced stressor can influence this relationship, making it either more or less pronounced. So what we see is that an individual, they might be genetically vulnerable to developing depression, but that depression is not going to manifest itself unless that individual experiences large amounts of stress. And that's what stress diathesis theory tells us. So this is a really good example of this gene-environment interaction. But genes and the environment can also work together when we look at these gene-environment correlations. So according to the concept of gene-environment correlations, our genes influence the environments to which we're exposed. So there are three types of gene-environment correlations that you need to know about. Let's start with the passive correlation. In the passive correlation, parents provide their children with environments that are influenced by their own, meaning the parents' own, heredity. So a passive genotype environment correlation is going to occur because biological parents, who are genetically related to the child, provide the rearing environment for the child. So parents higher in intelligence, for example, might be better at reading and thus enjoy it more. And so they might provide more books for the child to read. So then the child who is both exposed to more books as well as exposed to more enthusiasm over books. And they already have a genetic predisposition for intelligence, and so they might become a very skilled reader, which can contribute to that intelligence. The second type of correlation is an evocative correlation. Children here evoke responses that are influenced by their own heredity, and these responses strengthen the child's original style. So an evocative gene by environment correlation is going to occur when a child's characteristics elicit certain types of environments. An example here would be really active and smiling children tend to evoke greater amounts of social stimulation than compared to a more passive, quiet child. And so this is just, this social stimulation is just going to continue to reinforce that smiling social engagement. Another example would be cooperative, attentive children evoke more pleasurable versus more punitive environments than uncooperative, distractible children. And then the last correlation is the active correlation. So we see this correlation typically as the child gets older. The tendency is for that child to actively choose environments by their own accord that complements their heredity. And this is really known as niche picking. So here, the child is choosing the types of environment that they want to be in. They're seeking out environments that they find compatible and stimulating. So children who are really active and social are going to seek out environments with a lot of social interaction, whereas children who are more shy will not. So we can use these correlations, these gene-environment interactions, to think about why siblings are different. Kale and Kavanaugh explained that there are unique genetic factors that may make some environments more interesting or rewarding for different individuals. And this process is really referred to as niche picking. So it reflects this type of genotype environment interaction known as the active interaction. So behavioral geneticists, they'll also talk about the importance of the passive correlations and evocative correlations to explain why siblings are different. According to Scar and McCartney, the relative salience of each type of interaction is going to change with development. So for infants and young children, parents construct much of their experience. So passive interactions are going to be more typical when you're working with an infant. As that child increases in age, as well as competence and accessibility to a wider range of experience, both active and evocative interactions will become more predominant. So you can really see how the relative importance of these different correlations change throughout development. And you can also think about how these different correlations and the gene-environment interaction might explain why siblings who are genetically related can be so different from each other, because they may be experiencing very different interactions or very different correlations with their environment.